Hello students, already I uploaded some important solutions on partial derivatives. You can check them. Now, today we will learn Euler's theorem, and this is a very important topic on partial derivative. So what is the statement? If u is a homogeneous function of degree n in xy, then xux plus yuy equal to nu, where n is the degree. And now we will know what is degree of a function. So a function f of two independent variables x, y is said to be a homogeneous function of degree n if it can be written as fxy equals to x to the power n phi of y by x. If we can write a function in this term where phi of y by x is a function of y by x terms, then n is called degree of the function f. Okay, now some type of question will come from this topic. First one is verify Euler's theorem, and second one is some other questions which we will learn later. So verify Euler's theorem for the given function fxy equal to x cube plus y cube plus 3x square y plus 3xy square. And what does it mean? That means we have to solve LHS of the statement of Euler's theorem and RHS, and if they both are same, then we can say that Euler's theorem is verified. So first you can see that fxy equal to this function, and we will calculate first the LHS, that is x del u del x plus y del u del y, and if this is equal to nu, then we can say it is verified. So fxy equal to x cube plus y cube plus 3x square y plus 3xy square, or this can be written as x plus y whole cube, and then it will be x cube plus 1 plus y by x whole cube, and this is also can be written as x cube phi of y by x. And what is phi of y by x? That is 1 plus y by x whole cube. So now LHS is x del f del x plus y del f del y. Now calculate this one. So x into del f del x is 3x square plus 6xy plus 3y square plus y del f del y is 3y square plus 3x square plus 6xy. Now this can be written as 3x cube plus 6x square y plus 3xy square plus 3y cube plus 3x square y plus 6xy square. So you can check that these we can write in terms of 3 into x cube plus 3x square y plus 3xy square plus y cube, that is 3 into fxy. So this is equals to nf, and what is n? N is the degree of the function. So Euler's theorem is verified. Let us solve this question where u equal to tan inverse x square plus y square by x minus y. Then we have to prove this given expression. Now see that since this is an inverse function, then the partial derivatives will be little bit complicated. So we will turn this into a simpler function. So just write tan u equal to x square plus y square by x minus y, and take this function as another, say vxy. Then we will apply Euler's theorem on the function v. So we can write this as x square into 1 plus y by x whole square by x into 1 minus y by x. Then you can see that we can write this as x into phi of y by x. This function is actually phi of y by x. Now you can see that since the function v is here, so we can write degree of vxy equal to 1 because this is x to the power 1. So by definition of degree, we can write degree of vxy equal to 1, and we will apply now Euler's theorem on the function v. So x vx plus y vy equal to nv, and n is 1. Now v equal to tan u, and then del v del x equal to vx. We can write del v del x as equal to vx, and v is a function of two variable x and y. So this can be written as del v del u, or we can write this as dv du, because v is a function of single variable u, and del u del x, which is equal to, and dv du equal to minus sec square u and del u del x. Now similarly del v del y can be written as dv du with del u del y. We are using here the chain rule. So it is equal to minus sec square u del y. Now we will apply all these value in the equation 1. Then x into minus sec square u ux plus y into minus sec square u uy equal to v, and v is equal to tan u. So solve this. So x ux plus y uy, if you take minus sec square u in the right hand side, then we will get tan u by sec square u with a minus outside. Now x ux plus y uy equal to minus, this is sin u by cos u and cos square u. So solving this, we can get sin u cos u, hence multiply 1 by 2, then we will be writing this sin to u. So x ux plus y uy plus half sin to u equal to 0, hence proved. So we have proved the expression. Now let's move on to another question. See, if u equal to x f of y by x plus g y by x, then we have to show these two expression. So there are sum of two functions actually. So let us start the solution. We can write these two functions as capital U and capital V. So let us write u equal to capital U plus capital V, where capital U is x f of y by x and capital V equal to g of y by x. Now you can see that u and v are two functions which are homogeneous of degree 1 and 0 respectively. So we will use separately Euler's theorem on u and v. So for u, Euler's theorem gives x ux plus y uy equal to u, because degree is in this case 1, and x vx plus y vy equal to, since v can be written as x to the power 0 gy by x, then degree of v is equal to 0. So this is equal to 0, equation number 1 and 2. Now we have to calculate x ux plus y uy. So x ux plus y uy equal to, since u equal to capital U plus v, so we can write capital Ux plus capital Vx plus y into capital Uy plus capital Vy. Hence, if we separate this, so x ux plus y uy plus x vx plus y vy. Now we will use equation 1 and 2 in this case. So this gives u plus 0, that is u, which is actually x f y by x. So write x f of y by x. Hence we proved the first expression. This is done. Now we have to prove the second expression. So let us start the second expression. So from the first part we have x del u del x plus y del u del y equal to x f of y by x. Also we can write this as x del del x plus y del del y over u equal to x f of y by x as an operator. Now if we apply this same operator again, then x del del x plus y del del y to u equal to x del del x plus y del del y over x f of y by x. And as you already know, x f of y by x is, we can write as u. So this is x ux plus y uy, and from the first part we can write this is equal to u. So now main object is to do the LHS. So the LHS is x del x plus y del y power 2 u. Hence, this is equal to x del x plus y del y applied on x ux plus y uy. And then we will use separately x del x over x ux plus y uy plus y del x over x ux plus y uy. Then derive with respect to x, so it will be x square uxx plus derivation of x with respect to x is 1, so x ux plus derivation of y with respect to x is 0, hence xy u xy plus similarly do for del y, so it will be xy uxy plus y square uyy plus y uy. Now write x square uxx plus 2xy uxy plus y square uyy and write this x ux plus y uy together. Then we will use the previous Euler's theorem. So x ux plus y uy, hence we can use the previous equation number 1 in this case. So x square uxx plus 2xy uxy plus y square uyy, and using the first part we can write x f of y by x in this case. So x f of y by x. Also RHS is u, and you can see x f of y by x is actually u. So we have now x square uxx plus 2xy uxy plus y square uyy plus u equal to u. So this will be cancelled out, hence the final answer is x square uxx plus 2xy uxy plus y square uyy equal to 0. Hence the second part is also proved. Now you can note down, this is a very important note, x square uxx plus y 2xy uxy plus y square uyy equal to n into n minus 1 u. This is a very important note of Euler's theorem. Next, move on to the next question. So again cos inverse x plus y by square root of x plus square root of y. Then we have to prove this expression. So write cos u equal to x plus y by square root of x plus square root of y and take this as another function v of xy. Now find the degree of this v. So we can write x into 1 plus y by x and square root of x into 1 plus square root of y by x. So the part of y by x is phi of y by x and x to the power half multiplied with it. So the degree of Vx, that is n, equal to half. Now we have to apply Euler's theorem on the function v. So write x Vx plus y Vy equal to nv and n equal to half. Now we have to calculate Vx and Vy. Since v equal to cos u and v is a function of x and y, hence Vx, that is del v del x, equal to dv du and del u del x by using chain rule. Then dv du is equal to minus sin u multiplied with del u del x. And similarly we can write Vy equal to minus sin u del u del y. Hence applying all these values in the equation 1, we can write x into minus sin u ux plus y into minus sin u uy equal to half v and v equal to cos u. So x ux plus y uy equal to minus 1 by 2. If we take minus sin u in this side, then it will be minus 1 by 2 cos u by sin u, that is minus half cot u. Hence take this in the LHS. So x ux plus y uy plus half cot u equal to 0. Hence, we have proved the expression.